System design, it's one of those skills that really separates a good engineer from a truly great one. But what if I told you the path to greatness isn't about building the most ridiculously complex, future proof system you can imagine? What if the real secret is figuring out how to navigate the incredibly complicated path of building something simple? Let's dive into that. So, get this. This quote comes from an engineer who was on a project that almost completely failed. Why? Because they poured all their time, all their energy, all their resources into building this massive, complex rocket ship when all the business really needed was a reliable car to get from point A to point B. This is the classic trap of over-engineering, and believe me, even the smartest teams fall right into it. All right, so that brings us to our first big idea, the complexity trap. Why do so many smart, capable teams end up building these incredible rocket ships when a simple car would do the job just fine? It's a huge question, right? And the answer is, surprisingly, human. I heard this story about a startup that almost went bankrupt migrating everything to Kubernetes, which, is a super powerful, but also a super complex system. When the founder was asked why they did it, none of the reasons were actually technical. It turned out their engineers wanted the experience on their resumes, and they felt all this pressure to adopt the latest cloud-native trends. It had literally nothing to do with what the business actually needed at that moment. And that right there, that gets to the absolute heart of the problem. The truth is, a lot of the time, we as engineers are chasing the prestige of working with complex, shiny new technology. It stops being about solving the customer's problem and starts being about the status that comes with using a fancy architecture. So, how in the world do we avoid this trap? Well, we start with a really core principle: design for today, not forever. This is all about being pragmatic, being realistic about how we build and scale our systems. Okay, so on one side, you have the advice you hear all the time: build for this massive 100x user explosion right from day one. But then you look at a place like GitHub, and they do something totally different. Their philosophy: just build for the next order of magnitude. If you're at 1x today, just solve for 10x. It's a much more focused, much more rational approach that keeps you from getting lost in hypotheticals. And this is how that plays out in the real world. You start ridiculously simple. I'm talking a single virtual machine. That can often handle your first 1,000 users, no problem. Then you scale vertically. And seriously, people sleep on this part. You can get VMs with hundreds of CPUs and terabytes of memory that can carry you an incredibly long way. The rule is simple. Wait until you actually hit the limits. Say you're at 80% capacity before you even think about adding the complexity of horizontal scaling and sharding. Now, following the step-by-step approach leads us to a really fundamental shift in mindset. See, this old idea that software is something you build once and then you're just done, that's not just outdated, it's downright dangerous. I mean, this is such a crucial point. We have to stop thinking of our systems like static buildings and start thinking of them more like living organisms. They need constant care, constant feeding, to fight off this natural force that's always trying to pull them into chaos. You see this old mentality all the time, right? Especially in big companies. Let's make a huge, one-time investment in a piece of software that's supposed to last a decade. But the modern reality is that software is a continuous investment. It's an ongoing operational cost, like keeping the lights on, not a one-and-done purchase. You have to keep nurturing it to keep it alive and useful. And that force we're constantly fighting, it has a name. It's called entropy. In the world of software, it's this natural decay a system experiences. If you don't do the continuous maintenance, the security patches, the upgrades, it will inevitably become more disordered, more buggy, and less reliable. It's basically a law of nature for code. Okay, so if we have to keep pouring time and money into this stuff, how do we know if we're even doing a good job? Well, it's not about how clean your code is or how elegant your architecture diagram looks. It's about something much, much more concrete. Yes, this is the question that keeps so many of us engineers up at night, isn't it? How do we, as the technical folks, justify the investment we need to fight that entropy to improve the system? How do we bridge that massive gap between engineering and the business? You do it by learning to speak their language. And this slide right here, this is your Rosetta Stone. High database latency is an abstract technical problem that makes eyes glaze over. But $50,000 lost per hour of delay, that's a business emergency. System instability is a tech concern, but life-threatening risk to operators, that is an unacceptable liability. You have to translate technical issues into the language the business understands: money, risk, and competitive advantage. And that's why this is all so important. Because when you're a professional engineer, this isn't just a hobby. Technical craftsmanship, it matters, of course, but your success is ultimately measured by the value you deliver. The most beautiful, elegant code in the entire world is completely worthless if it doesn't positively impact the business. So let's pull all of these ideas together. What does this coherent philosophy for a great engineer actually look like? Okay, here it is, boiled down. First, always prioritize simplicity. Next, solve the problems you actually have today, not the imaginary ones you might have in 5 years. Then, scale in practical steps, just one order of magnitude at a time. And this is a big one. Treat your software like a garden that needs constant tending and investment. And finally, maybe the most important part, measure your success by the real, tangible impact you have on the business. And so, we end right back where we started. You know, at first glance, a simple system seems, well, simple, easy. But when you are operating at a massive scale, just keeping that simple system running, reliable, and performant is an incredibly complex challenge all on its own. So why on earth would you choose to add unnecessary complexity on top of that? The real art, the true mark of a great engineer, is mastering the profound complexity of keeping things simple.